today we have the device management and LTE-M session with Olivier Carmona from IoTerop, and he is the head of sales of marketing in IoTerop with over 20 years of experience in IoT and consumer electronics industries. And he will introduce himself better than I did in a second. And also Miguel Lira from Urban Control, he's the director of Urban Control Limited, is joining Olivier for this session, and we are very thankful to have him here. Miguel has more than 25 years of experience in the electronics industry, and he's currently the director of Urban Control Limited, which is a UK-based IoT solutions provider, currently focusing on delivering end-to-end smart city applications. And for today's session, Olivier will deep dive in lightweight M2M protocols a lot in detail, and Miguel will give an overview on the real-life applications. And just before giving the word to them, I would like to mention briefly the housekeeping items. Today's sessions will be 60 minutes, including Q&A session. Questions are, as always, encouraged. Please ask your questions using the Q&A feature, and I will forward your question to our speakers at the end of the session. The session again will be recorded and will be sent afterwards. And at the end of the webinar, you will see a feedback form. So please tell us how it went so we can do better for the upcoming sessions. And with that, I would like to hand over to our speakers of today.
Thank you, Genset. I'd like to take, so I'm Olivier Carmona. I'd like to take the occasion to thank you, Genset, for organizing that event, and to you and to Afzal and all the IoTCreators team. It's an important step, I think, for the industry to be well aware of what narrowband IoT and LTE-M are bringing to the table, and I'd like to thank you for that and for all the efforts you are making towards the industry to help grab the industry grab what the cellular IoT is doing. So thanks, Genset.
Yeah, thanks, Olivier. Amazing feedback.
Can you see my screen?
No, not yet.
Okay, I'll do that. Can you see it now?
It is loading. Yes, we can see your screen.
Okay, thanks. So I'd like to go over a quick presentation today of who we are quickly. Why device management should not be something that you discovered because you are not able to scale up. And I'll go through a quick lightweight M2M 101 so that you get what's lightweight M2M in a few words. And then I'll try to kill some myths about lightweight M2M. And then we will have Miguel from Urban Control that will give an example of how lightweight M2M can create sustainable smart cities. So first, who we are. So we are a company that is bringing software to the industry to help scale your deployment. Today, we are, thanks to Cellular IoT, we have a large deployment of massive deployment of IoT devices, and to be able to scale those devices up, you need a solution that will be able for you to do all the nasty things that requires a device to be installed, maintained, and so on, without killing your operational expenditures. And that's where we have been from the beginning of our activity. We have having had this vision that we need to empower the companies to be able to have the best tools to harness the potential of massive IoT. Massive IoT is not only about deploying large devices, it's also bringing some economic and environmental sustainability to their maintenance. And that's where we really are being helpful here. So, of course, you are all familiar with the fact that there is a huge burden for IoT, which is how to maintain the security of those devices that are getting more and more common around. We have had a lot of trouble rounds that have started. There is a regulation which are a European regulation which is starting up. All of those regulations start by saying you need those devices to be at least updated. And that's part of the device lifecycle management. You need to be able to install that device, update it, decommission it, and you need to do that remotely. You need to be able to remotely update it. You need to remotely control it. You need to be able to also have a way to do those operations without killing your budget. And so you need to automate those maintenance activities. You don't need to have to act on a device precisely, but you need to be able to, for a given device, you need to be able to have a solution for that device and apply it to all the fleet or all the part of the fleet that you need to access. For that, you need also to be sure that what actions have been, who has been accessing that device tool, that device management tool. You need to record all the action performed, and so that you can help any regulator to know what has been going on into your device, who has been doing what, and that's really what device lifecycle management is about. Now, device lifecycle management is not possible everywhere. We have been going through a story where the 2010 IoT was sort of thinking that the most important fact was you get data to the cloud. No, this is first Internet of Things is about internet. So internet should go till the end device. It should not stop at the gateway. So the Internet of Things is first and foremost that. And second, you must have a way to reach the device. You need not only to be able to have the device to report data to the cloud, but you need the cloud to be able to ensure that the device on the other end is really the device that's talking. You need to have an integrity check. You need also to be able to update that device. You need to be able to remote control it, and not only a few actions, and not only actions that can be unreliable, because Sigfox was not proposing any backward or back channel. LoRaWAN is proposing still a back channel, but that back channel, that information going from the cloud to the device is extremely unreliable. And that unreliability makes the story completely impossible today with LoRaWAN. And we've tried, we have implemented a lightweight end-to-end over LoRaWAN, but that cannot fly today. To the cellular IoT, it's the first technology which is bringing that internet connected devices really connected directly to internet and in two directions. So being able to not only send the data to the cloud, but also be able to do some operation on the device. And that's really something that is coming up. Of course, LTE-M is a solution that exists, and it's an option. Now, it's all depends on what is your budget. If you have the budget for LTE-M, go for it. But narrowband IoT is 3 times less costly, 3 times less costly in CapEx, 3 times less costly in maintenance too, because the connectivity cost is also lower, and many of the features being made for low battery, you will be able to maintain it on the long run. So that's two different technology, LTE-M and narrowband IoT. And definitely narrowband IoT is really here to provide for the people that can work with high latency, because it's not an immediate, it's a 10 seconds, 15 seconds latency that you can expect on that network when you send a message and you receive it. So if you can live with that, then narrowband IoT is your play. If you need lower latency, then you can go for LTE-M, but expect some overcost compared to narrowband IoT. Then what is the device lifecycle management protocol which is existing around? Well, lightweight end-to-end is the de facto one for IoT. There is no other alternative today. And what I mean by device management, so lightweight end-to-end brings you the device management, the remote, the automating or defining the configuration and the update of your device, the bootstrap of your device. It also defines how you can onboard the device. It defines how a device can report it's alive when it's coming back to the network. So it can register back to the network and say, to the server, I'm here, send me back some information, so you can register that device so that you can work with it. You can also, it defines also all the semantics of operations that you can achieve on that device and all the resources that are contained on that device. You can also, it defines also the encryption, the authentication and the authorization that a network requires. So all what you need to have a multi-tenant system. It's also a solution which provides you all what you need to know what the device is providing. And last, it also provides you all the data format, the data encoding, how data is encoded between the device and the cloud, but also how the data is represented. So it provides some object model. And it's important because Lightweight M2M is not a transport protocol like MQTT or CoAP. It's a device lifecycle management protocol. It's an application protocol that brings with everything that you need to do the device lifecycle management. So the power of Lightweight M2M standard is twofold. First, it provides you the device interoperability. That means that once a device is implementing Lightweight M2M, whether it's a temperature sensor, a humidity sensor, a pressure sensor, a car, a light sensor, whatever, you'll be able to interact with a Lightweight M2M server. And that server will be able to conduct a firmware update for that device. And whatever the brand, whatever the nature of the device, you'll be able to find a firmware object that will be able to update and to maintain. And that is the first thing. You have a device interoperability, which is crucial when you scale up. It's also true that the data model that Lightweight M2M is bringing is also crucial into the power of Lightweight M2M. It does provide you a way to manage thousands, defines thousands of objects. You have a Lightweight M registry objects table that is maintained by Open Mobile Alliance, that contains objects from other alliances like GSMA, 3GPP, UCFI, and 1M2M. So organizations that are providing solutions for the telco industry, for the smart city industry, for the overall IoT ecosystem, and they provide you the most common device management use cases. So you will be finding the definition of a light, of a door, of a waste sensor, plenty of examples that are crucial to you, and it's an essential part of Open Mobile Alliance, and it's open for contribution. I'll talk about it later on. So why Narrowband IoT needs Lightweight M2M? Lightweight M2M is simplifying really your experience. If you go without Lightweight M2M, you will have to reinvent all what I mentioned before. You will have to select a transport protocol. You have to select the secure transport layer. You will have the encryption layer, sorry. You will have to select also your object data model. You will have to define how you will be installing the device, how you will bootstrap the device, and then you will have to build on top of that. You will need to build all the tools that you will require to automate those operations. And it's basically restarting everything that is already tested and working for millions, hundreds of millions of modules, because as you know, Lightweight M2M is already used in the field by the telco operators for their modem. So the modem from Quectel, Simcom, Thales, Telit, and more, and all the devices must have Lightweight M2M because it's a certificate which is needed for them, because the telco has been using Lightweight M2M from the beginning to manage the firmware update of those modems, to ensure that those modems can be updated in case they could break the network, and that they need to be updated to avoid breaking the network, and also to provide some connectivity statistics to those operators. So that's already a solution that works. So you have a solution of either go crazy at reinventing completely the wheel, or go easy and use Lightweight M2M. So now that I went through those, I just want to go maybe now into a Lightweight M2M 1.1. So what's Lightweight M2M? So Lightweight M2M consists on, if you look to the left, to what we call a client device. Here it's a sensor, here it's a light a light controller. So that light controller will have some what we call objects, lightweight end-to-end objects. Here precisely you have an object which is called the firmware update, an object which is called the connectivity monitoring, another object called location, and the fourth one, which is light control. So those four objects help you define what the device will be able to expose, what the device will be able to do, and what the device will be able to inform the cloud. And here on the other end, on the right end, you have the lightweight end-to-end server. The lightweight end-to-end server will be able to act upon the device, and it will be able to do some operations like read the status of what's the location of the device, what's the light control status. It will be able to write a light control command. It will be able to execute an operations like execute a firmware update, and will be able also to do some to get some notification on, for instance, the location, if the location change, or some information about the light sensors that can be on the light control C device, and that will inform about what's the level of light today. So that's the very basic terms. So clients, servers, objects, operations that you can conduct on lightweight end-to-end. It's important to, again, on objects, it's very important notion, the object, because it's an interface for each of the features of a device. It's a crucial part of how you define it is extremely crucial inside lightweight end-to-end. And it provides all the behavior and that you will be able to drive for the device. It benefits. It's a big benefit because you will be able, through a server, without knowledge about the device, you'll get information about what are the capabilities of that object, and you'll be able to manage it, whatever the device is. You will be also to be able to update the firmware with every device as soon as they have the firmware object update, firmware update object. They will be able to you'll be able to conduct the same process for water meter or for a connected car. But what is an object? So lightweight end-to-end is really built for IoT. It's not a lot of bells and whistles. It's extremely compact. Here you can see the nature of an object. So if you look at the objects on the right, you have a device object, and it has three resources. It has a connectivity monitoring object. It has a temperature object, which is a 3303. So 3303 is what so 3303 here is the nature, is the definition of a temperature object inside the lightweight registry object. The number 4 is the connectivity monitoring object, and number 3 is the device object. All of those objects are made of some resources like serial numbers that you can read, a reboot operation that you can execute, the current time that you can read or write, and all of those operations, all of those things are defined inside the lightweight end-to-end registry object, and each are defined by a 16-bit ID, which is the 3303 here. So they call all of those resources can be accessed. So either you can access the device object. So 3/3/0 will give you access to the device object for that given device, or you can access the serial number 30332, and you can do an operation like read /3/0/2, or you can read the temperature objects, read /3303/0/5700, and you'll be able to read the first sensor value here, and you'll be able to read the unit that you are measuring the temperature with. So let's go into an example. For instance, we can think about a sliding door, which is made out of two present sensors, one at the entrance, one at the one internal, one external, that help you open the door either for entry or for going out, and you will be able also to have a few things that you want to do, like count the number of activation of that door. So you can first take the presence sensor, the presence object. The presence object is defined by IPSO. It's an object which helps you define what's the current state of the present sensors, whether it's present or not. It's a Boolean. You can also have some counter about how many objects. You can reset that counter. And you also have some informations like the busy to clear delay that are a way for you to sort of be able to fine-tune your device in terms of timing. So that's the definition of the presence object. But if we think about the door itself, we don't have a door object inside LWM2M registry. So and let me go a bit deeper into what are the objects. So you have a gallery of objects which are defined by Open Mobile Alliance, which are from 0 to 123. You have after that a set of objects which are registered by third-party organizations. After that, you have objects registered by companies or individuals. Those are defined by companies, not necessarily defined EVD, but because they are used in an open system, they don't want to be override. Everybody can submit a registration. And then you have IDs reserved by vendors. And last, you have a pool of numbers that you can use freely, but at the price of being sometimes not used because you can overlap with existing devices. So you have it's a 16-bit IT, so you have 65,000 devices model possible here. If we take the example of creating an object, so we can create a custom object, and we can, for instance, create a door control object, that could consist into a door state, whether it's open fully 0, so open fully 100, and closed 0, and you can also tell whether the door is in automatic mode, if it's or if you want also to send some commands into setting the point of the door, so you can force the door remotely to be between 0 and 100, and you can also act upon the closing delay, so when the door will be how long the door will be taking to open and close. If we put that all in action, that makes a solution where you'll be able to read and write and execute all those operations on the three, so the two presence sensors and the door control. The two presence sensors being part of a lightweight M2M registry database, and the door control that has been customly defined by you. So that's extremely simple. But it's very important that when you define the object, that you made it in a proper way, that taking example from the OMA database and use them for your purpose wisely. So now I'd like to go through a few myths that you may have heard about lightweight M2M. So lightweight M2M is often compared to a transport protocol like MQTT. It has nothing to do with it, because lightweight M2M actually works on top of MQTT. So you can use lightweight M2M on top of MQTT, on top of HTTP, on top of CoAP. Most of the people know about CoAP, lightweight M2M over CoAP, and most people know lightweight M2M over CoAP over UDP. And yes, it's the most common. But what it adds to an existing transport protocol, it adds things like a bootstrap. A bootstrap is a very complex process that is all specified by lightweight M2M, and that is certainly easy to use. It's the concept of when you start a device, you can bootstrap it, and it will be going on a bootstrap platform, which is a given IP address, a given server, to which it will be able to be identified with a key delivered by the manufacturer, delivered to the manufacturers by the OEM. And once that key has been authenticated, the device will be given the production key and the address of the production platform so that it can work then after with the production platform. That means that the manufacturer to which you have the OEM would have given the power to make that device will not know what's the production the IP of the production platform. Never he will have the production key at any moment with him. And that simple action is defined by Lightweight M2M. It's not a transport protocol, it's a device management protocol. Another myth that we also know is Lightweight M2M is all driven by the server. Yes, it's true that Lightweight M supports read operations, that the server can read in that sense. It's also true that a server can ask to be to observe a status of a given variable. So you can ask a device to report on every 50 minutes, every hours to report its status. But it's also true that a device by itself can just report and without the need of the server sending anything. So a Lightweight M2M send operation allow a device to report directly to a server without the need whatsoever that the server says something. So of course, this is not something that you find with oldish 1.0 servers. It's a Lightweight M2M 1.1 that starts to give that, but it's important that you know about it. Another important thing is you are dependent on the server. You have certainly some dependency on the server, but you also inside Lightweight M2M you have definition of fallback. So you can, in case you don't have the server is not appearing, you have fallback rules that can apply and make the device resilient to those risks that can happen. Another thing is also that people say that a bootstrap operation is particularly long. It takes the device a long time to get all the data. You need a long period where the device needs to receive the data. Yes, it's true with all these 1.1 version, but 1.2 allows you, Lightweight M2M 1.2 allows you to do that in one operation so that you don't have to wait. And that's one pack. Not last, but another thing which is important, it's often people think that Lightweight M2M don't work on unreliable connection. And here, Lightweight M2M over co-op, over UDP does work into unreliable network. And there are a lot of possibilities that are offered by co-op to manage congestions. And you can definitely make it work even on very difficult network conditions. And as I mentioned before, Lightweight M2M works over co-op, over UDP, but Lightweight M2M works over MQTT, works over HTTP, over co-op, over TCP, co-op over SMS, and even co-op over LoRaWAN, if LoRaWAN was able to provide some backward channel, which is not the case today. And that's important that you know about it, because it's not only one thing. You can also do co-op over narrowband IoT NIDD, non-IP data delivery, which is also an important definition that Lightweight M2M is providing. So you can use Lightweight M2M over non-IP data delivery too. And last, because Lightweight M2M is often used with co-op, and often people believe that, and I've seen that recently in a post with Julien Vermeer, that co-op is not built for large payload because you have to wait when you send when you work in block mode in co-op and you want to start and launch a large payload, you have to wait that each block gets acknowledged. And no, there is a mode that has been defined by RFC 9177 that allow you to provide all the blocks at one time, and at the end you can define whether that is if a block is missing, you can restart only for the block missing, the missing block, and not redo all the operations. So that's an important mode, that the transmission mode to the quick block mode transfer is an important thing. So if I go over the key takeaways, so LWM2M and LTE-M provides you all the features for communication and device management in an IoT system, and it provides you all the necessary objects that you need to provide and scale up your deployment. Designing an object is easy if you take into account all the definition that you have into the database already. You can take example from it. So a short word before giving the hand to Miguel. Miguel and Urban Control and other customers selected IoTerop not only for its deep technological and expertise in LWM2M and LTE-M, but also in our capability to answer your questions and being able to be extremely flexible. And also help you not only at your project, but in your vision. And because we help shape the future of IoT, we do have some important value to share with you. We are a member of the board of Open Mobile Alliance. We have been, and David Navarro has been defining a lot of specification, and our team has been helping into providing a lot here to help the Open Mobile Alliance provide a real solution for Internet of Things, and we are encouraging you to join the Open Mobile Alliance and be able to bring the future further in some industry where we are maybe underrepresented. And I'd like also to also acknowledge and thanks Frost and Sullivan for recognizing us as a really important smart solutions for the smart metering ecosystem. We are bringing to those ecosystem the capability of Alaska, our device management platform that is able to scale millions of devices, support intermittent connectivity, and provide you end-to-end securely. And we also provide you not only the platform, but also the client. And we are unique in providing the most compact solution, 10 times smaller than our competitors. And not only it's small, but it's extremely easy to use, and it can help you bring your devices extremely quickly to the market, and with not the latest LWM2M implementation, but the latest LWM2M implementation that you need to get your device efficient, memory efficient, energy efficient to the market. Our customers range from metering, like EDMI in the field of water metering, Elvaco in the field of heat metering, but also container tracking with TrackSense, with city lighting, with Itron, smart building sensors underneath. So don't hesitate to join us. And I'd like to give the floor now to one of our important customers, so Urban Control, an expert at Smart City. Miguel.
Thank you, Olivier. Good morning. And thank you all that joined for this session. It is a real pleasure to be here with my colleagues, having the opportunity to present my view on technologies for smart cities and how important is the device management for massive IoT, as well as using the proper communication protocols, such as lightweight machine-to-machine. So, Jean said already a bit of myself. I'm Miguel Lira. I'm Innovation and Development Director of Urban Control. I've been around working in the electronic and control industry for the last 25 years, focusing on the last 15 on outdoor connected solutions. A quick introduction of Urban Control. We are a private UK company running year 7 of operation. And since 1 year now, we are part of a bigger family. We were acquired by the Lucico Group. We develop IoT solutions for smart cities based on technologies and open standards that we consider the most relevant in this industry. We also have a proven track record of projects, counting with a few hundreds of thousands of devices deployed in several regions of the globe. Olivier, thank you for passing to the next slide. I would like to present, our definition of a smart city. Of course, there are several definitions and interpretations of what a smart city is, but in general, we can agree on some common characteristics. It's an urban area, but not only, as many projects can be extended beyond the urban area limits. It uses some form of electronic technology to collect and gather data from from physical devices like an air quality sensor or traffic counting camera, from an asset, the luminaire, a bridge, from people, tracking people's movement, density of a crowd, for example, and from other sources of data. The data is then sent through a network that is connected to some backend service that will process and use it to manage more efficiently the city's assets, services, and resources, reducing energy costs, carbon emissions, and light pollution, which will lead to a more sustainable and attractive city to live in, which is usually the ultimate goal of a municipality or an authority that runs a city. Also note that with half of the world's population living in cities, millions and millions of smart IoT devices are expected to be deployed during this decade, which will raise a number of challenges that need to be overcome by the proper technology selection. So there is a wide range of options when it comes to IoT technologies, but not all are suitable to overcome these challenges imposed by the requirements of a smart city. Ultimately, the choice of a less fit technology will dictate the failure of a smart city vision. So there are critical factors that we must consider when making an evaluation of the most fit IoT solution. And usually they relate with the network complexity, what is the effort to have a network infrastructure in place, and its coverage, the availability of enough signal to connect to that network. The bandwidth, the volume and number of simultaneous connections, the data throughput, so the speed of the communication, the latency, which can be defined the delay between the action and the response, and the resilience, the resistance to disruptions. There's also device constraints, the cost, data privacy and security, and standardization, interoperability. So in the next slides, we will explore a bit more in detail these key factors, comparing the most commonly used IoT technologies. Coverage. Designing a good network infrastructure to provide enough coverage is a complex task, requiring a high level of expertise and capital. The network coverage will be influenced by the signal availability spread around the city and how far each IoT device may reach per hop. The topology of the network, mesh or star, for example, also plays an important role on desired coverage. And it may imply a high number of network components to achieve the optimal coverage. The frequency spectrum used also impacts the speed, the range, and building or underground penetration. If the IoT device is mobile, then only a few network types will suit the application, the mobile networks. Right? Some of these networks are already in place and reduce a lot this complexity, providing widespread coverage even at a country or global scale, as the existing cellular NB-IoT and LTE-M technologies supported by the 4G and the 5G networks. Next, please. Olivier, can you just go to next? Very good, thank you. Bandwidth and data throughput. Bandwidth is shared across the entire network, and it affects both the volume of messages IoT device can send and the size of the data packets they include. A lot of IoT applications don't require much data throughput, but if your device involves processes like streaming video or transmitting real-time data, speed is vital. Data throughput is also important if you plan on delivering remote firmware upgrades to keep your device secure, fix bugs, or add new features. The ability to deliver firmware updates over the air helps future-proofing your devices, but without enough data throughput, IoT manufacturers can send them to battery-powered device, or they would drain the batteries otherwise. And slower technologies, as the ultra-narrowband, Sigfox, for example, suffer from this problem, and working at speeds of 100 bits per second only, it struggles to keep the device constantly updated and secure. Power consumption. Power consumption of IoT devices is a combination of factors like the network topology and the role the device plays on keeping it running. If you think about the mesh topology, where every device may be requested to participate as an active element of the network itself. Data throughput, so the faster the device transmits and receives data, the less on airtime it needs, and therefore you will use less energy. And even regulatory limits imposed to the radio's power will influence its power consumption. Network's power consumption also depends on your use case. For example, how often do you need to transmit? If it's bidirectional, the number of real-time commands issued, and if it's battery powered. In this case, the battery has to last for the entire life cycle of the device, and that means your connectivity solution can consume too much power. Some specialized solutions like NB-IoT and LTE-M have power-saving features to extend the life of the battery of the IoT device, which can last for a decade, honestly. Cost. So all the previous mentioned factors will impact the cost of the IoT solution, as nothing usually comes for free. How we combine them will dictate not only the capital investment needed from the city, but, and many times more important, the ongoing operational costs that will carry for many years to come. If a network is already deployed and you simply have to connect your devices to it, like the cellular network, the deployment costs won't include buying and building network infrastructure. But with any other network technology, you will have to evaluate the equipment you need to connect to it, such as the radio modem, the SIM card, or something you'll need to acquire again and again for every deployment, such as gateways or routers. Deploying proprietary connectivity infrastructure adds ongoing maintenance and operation costs, which will require also to invest in personnel, technical expertise. More complex networks may also increase your development costs, as your device will need to be compatible with proprietary protocols and technologies the connectivity solution requires. And of course, you need to consider the ongoing costs of power and data consumption. With increasing deployment and adoption of narrowband cellular networks, affordable data plans, and a more compact and efficient hardware, the LTE and NB-IoT technologies are becoming much more cost-attractive. Security. With billions of IoT devices projected to be connected to the cyberspace, IoT security is a critical aspect of a smart city solution. Today, most of the transmitted data is still pretty much unsecure, and IoT devices can be hijacked and hacked to be used as an entry door to your network, granting a hacker access to computers, servers, and other entities on the same network. Firmware updates are crucial and allow to repair breaches in IoT security. But not all network technologies will enable to deliver them because they have limited bandwidth or limited security capabilities. Security must be designed and implemented from end to end, including the device hardware, its embedded software, the communication protocols, and the servers on the network. So how different is it between IoT technologies? Let's compare them a bit. Cellular NB-IoT and LTE-M. So this is the latest technology that uses widely available 4G and 5G cellular networks. It provides a high return of investment along with low latency and high speed, suitable for all scale of deployments, so from smaller projects to a complete city. These regulated networks provide very high level of security and operate through open-based standards, providing greater interoperability. It is also easy to embed in connected IoT solutions, like sensors, for example. The LoRaWAN. This technology has seen a recent decline in deployments. System is promoted as based in open standards, but the chipset is only available via one vendor, so it limits interoperability. Network coverage is also limited, which also affects latency at longer distances. It requires a separate network infrastructure, and it's mostly suitable for privately owned deployments. If you think about the sub-gig mesh networks, they are very secure and promote scalable networks, operating through open-based standards as well. These mesh networks provide good interoperability, but require a separate network infrastructure. They're also mostly suitable for large-scale deployments. And the ultra-narrowband, which is an older technology that requires a separate network infrastructure, also suitable for large-scale deployments, but it has a limited bandwidth and proprietary system, which limits its future-proofing. So I'd like now to refer the importance of the interoperability. Is a characteristic, think about interoperability, is a characteristic of a product, of a system, to work with another similar products or systems from different manufacturers, allowing data exchange using open standards. Note that when we want to adapt its solution to a proprietary system, we will be speaking about compatibility and not about interoperability. Interoperability is a key topic for smart cities. Proprietary IoT solutions frequently lead to vendor lock-in, difficult and expensive integration with others, and poor or non-updates, and eventually its obsolescence. With increasing standardization at all levels of the solution, like lightweight end-to-end, using UCFi or Talk, with increased security features, with wide network coverage, and the proper device management, scalable deployments and future-proof solutions are becoming a sustainable reality for smart cities. So which IoT technology will be the best fit for a smart city? Obviously, there isn't one single technology that will fit all requirements, but decisions should favor technologies that minimize data consumption, energy usage, and the overall cost, and maximize network and complexity and coverage, bandwidth and data throughput, security, and the interoperability between devices and systems. All things considered, this combination can be mostly achieved with today's low-power cellular NB-IoT, LTE-M, and with Wi-SAN mesh networks, using open standards for interoperability. So after much said about IoT technologies, network types, and communication protocols, I would like to present a real use case based on the latest cellular low-power NB-IoT and LTE-M connectivity using the interoperable lightweight M2M communication protocol and a powerful professional device management platform. Let me show you a short 50-second movie section with the Urban Node 324 cellular outdoor lighting control in action before passing to some details of its architecture that makes it so simple to deploy on the field. There was some audio coming together with the video, but I think it's good enough to show how simple it is to deploy a device like this. So how do we make it that simple? The whole concept of this device is to make it really plug and play straight out of the box. So what is the key to the simplicity and the easy adoption of such solution? We consider three major critical factors when developing this solution. It had to be based on open standards to promote interoperability and decrease vendor lock-in situations. The connectivity had to be based on a global network, widely available and highly reliable, with no setup or expertise required for its operation. And the communication protocol and device management platform had to secure and optimize message exchanging with the field devices, automate tasks like firmware updates over the air and others, be able to scale up to millions of devices, and allow the interface with third-party applications. In the next slide, I'll give you a very fast device is modeled by objects, each representing a core function of our device, like its geographical location or electrical monitoring of the street light, containing a set of features or resources related with that function. These objects are public, they are standardized, and their specification can be found on the Open Mobile Alliance Lightweight M2M Object and Resource Registry site, which I believe also Olivier shared the link. You use the ones that better describe or model your lightweight M2M IoT device. Let's take an example of reading the active power, a resource from the electrical monitor object. By having both the lightweight M2M client library embedded in the device and lightweight M2M object scripts in the device management server, The communication protocol ensures that a very small amount of encrypted data is exchanged between the server and the device in order to get a reply to the read request with a very low latency. And then if you click the next slide, then we use the device management platform, RESTful API, to a third-party system like a TOLC-compatible or TOLC-compliant central management software, and then collect data, monitor, and control the device. Like mentioned at the beginning, the ultimate purpose of deploying massive IoT technology is to manage more efficiently the city's resources, reducing energy costs and carbon emissions, making cities more sustainable and much more attractive to live in. In the next slides, I'll try to demonstrate the economical and environmental impact that this solution can bring to a community. So take the example of a town with an outdated 10,000 discharge lamps in its street lighting network, for which the municipality decided to invest in our solution. So no communications network expertise needed, very easy to deploy, and with a fast payback period in mind, the positive impact is felt immediately from day one. So if you think after 1 year of operation, the municipality has achieved a 75% energy consumption decrease with the street lighting, a 70% operational and maintenance cost decrease, costs that are getting increasingly higher day by day. They avoid the emission of 2 million kilograms of CO2 equivalent of greenhouse gas, safer and better lit spaces. They track and improve service level agreements with information provided by the collected data. And they are able to future-proof a solution that will continue to be secure and will allow future IoT integrations. Just to give another perspective, which I find very interesting, is the energy saved by this small project and the greenhouse gas emissions avoided are equivalent to, for example, 426 cars driven on the streets for 1 year, or 385 homes electricity used for 1 year, or just a curious data, 241 million smartphone charges. So just a small project brought a huge impact, economical and environmental. So if you think about the millions and millions of streetlight, points that we can manage and reduce this, this carbon footprint is huge. The benefits we can bring to a community, to a country, to the world. Anyway, this concludes my presentation. It is a big pleasure, and thank you very much for your time. I'll give the word back to you, Olivier.
Thank you. Janset, I'll give you the floor to ask the questions. We had a couple of questions asked.
Yes. Thank you, Olivier and Miguel, for this great presentation. And without losing time, I would like to ask you some questions. Questions are mainly about the lightweight M2M. And let me start from here. So, Olivier, you mentioned lightweight M2M clients, but what do you mean by the client? Is it the device or is it something else?
So, client is a software notion. It means it's the term used in software, but it's a client software that allows you to be run on a device, to be able to implement all the client property, to be able to answer to a server or to send data to a server or to notify a server, to notify information to a server.
Yes, thank you for your answer. Okay, another question about the comparison between lightweight M2M and the LMS. So it seems like a lightweight M2M does a lot of things like the LMS. So how do you compare lightweight M2M to the LMS, especially on the interoperability side?
So thanks, Martin, for that question. So DLMS is very much similar, but DLMS is a technology built for networks with high bandwidth, and it has been built for large capacity network. It's also, DLMS is not, I would say, a single device management technology. It's a definition of objects, DLMS custom objects. It's a definition of many things. You can pick and choose whatever you want inside the specification, but you don't have you have so many choices that the interoperability is hard to achieve in DLMS today. The other part, I would say, DLMS is also a technology that is very adapted to electrical metering today, and it's a technology that needs to be. I think that it would be a good combination for DLMS to add support for lightweight M2M. But the fact is that today, although there is some overlap, lightweight M2M is addressing the real constraints devices working on a constrained network, and DLMS is not that technology for that ecosystem for now.
Yeah, thanks a lot for your answer, Olivier. I think these two questions are quite parallel. So do we need a separate server for firmware updates on lightweight M2M, or does it support the firmware updates itself?
A server can be inbound or outbound. You can this is a design choice. You can pick either one or the other. This is just a design choice that you take. You can use a lightweight M2M server that will have that will provide the firmware updates with its own repository, or you can use an external one.
Okay, so design choice, as you also mentioned. Sorry that I'm going very quickly, but we are almost at the end of the session. So another question is, can I understand the usage of lightweight M2M and MQTT or co-op are different? In implementation, we can use lightweight M2M to manage devices and use MQTT for data management.
So lightweight M2M is a device management protocol that can run on a transport protocol. So the upper layer is lightweight M2M, and the lower layer is co-op or MQTT or HTTP. So you can pick lightweight M2M for the device management protocol and use MQTT, or use co-op, or use HTTP. So this is just, it is very important that you understand that the transport protocol, lightweight M2M, is independent of transport protocol. Now, in the fact, lightweight M2M is mostly implemented on top of co-op. Why? Because co-op is much more efficient than MQTT, and MQTT does not work on narrowband IoT and will never. MQTT is a technology which is built on top of TCP, and on top of TCP, you need synchronous communication. This is not working. TCP is not working on top of narrowband IoT because you have high latency networks on narrowband IoT. 10 seconds to get and run a synchronous layer is too much.
Yeah. Thanks, Olivier. Another question is, are there free configurable lightweight M2M server applications that can be installed on our PC, or do we have to use a remote host or service from the internet?
So of course, everybody can run an open source implementation on a PC. I don't think it will be matching with the security that you are expecting from your solution. So if IoT needs to improve its security capability, it's not to go for a non-premise solution run by your own PC in your own premises. I would highlight that it's highly risky to go into that direction. You won't be able to build a solution as reliable as Alaska or as IoTCreators from a PC running an open source implementation in your own.
Yeah, actually, there's another question that is pretty parallel to those. So for someone to try out lightweight M2M, where do you recommend to start, and how do you recommend to start, Olivier?
We have a GitHub where you can test and use Iowa. You have also, and I'll provide you for all that are interested. I can provide you some. You can type GitHub, IoTerop, Iowa, and you will be able to get access to the open source. And you have also access to our server solution that allows you to test and evaluate your device. It's a Connecticut, not Alaska, but Connecticut. So that's a good way to give a start. And you have other open source implementation, but if you want to go to production and be able to enter in devices that are extremely constrained, we are the only solution out there.
Yeah, we can maybe send the link to Iowa and its integration to IoTCreators as well, Olivier, for the participants, so you can also try it yourself.
Yes.
So Olivier and Miguel, do you have maybe like 5 more minutes more that we can continue with the questions, or do you need to do a sharp exit?
Sure,
No, it's
no,
okay
I have
for
a couple
me.
of minutes more. Yeah, sure.
Okay, perfect. I hope the audience also have enough time, because there are questions for both of you as well. So then I will continue with Olivier. Olivier, is there a recommended security for lightweight M2M application server? I'm only aware of the TLS, but is there another security layer? Or if not, is there intentions for defining a security layer in the future?
So yes, lightweight M2M defines 2 security layers. One is a link layer. It is DTLS. It's optional. You can also go with no security, but you can go either no security. You can use the link layer security called DTLS, or you can use the encryption, the co-op encryption called OSCORE, OSCORE. OSCORE, it's an Internet Engineering Task Force technology defined. It's a protocol that is much more efficient than DTLS, and that allows you to encrypt not at a link, but the co-op payload, so that you can encrypt it on the device and decrypt it at the application, meaning that if you use a server like Alaska, or you will be able to go and use your data, send your data without us seeing anything actually.
Yeah, that's the perfect answer. Okay, I continue then. What is the memory footprint of lightweight M2M client, Olivier?
So a normal lightweight M2M client would be 300 kilobytes flash. We are using 30 kilobyte flash. And in terms of RAM, a normal lightweight M2M client would be using 50 kilobytes of RAM. We are using 5 kilobytes of RAM. So it's 10 times less than our competitors.
Yeah, perfect.
And there is a question on CIoT.
Maybe. Thank you. I missed that one.
So the question also, CIoT is another way of talking about non-IP data delivery. So it's a technology of narrowband IoT. Narrowband IoT offers the capability to work either over IP or over non-IP. That's called the NIDD, also called CIoT. I can't remember what CIoT stands for actually. But I don't have any timer value to recommend you, Ashish, but I like to emphasize that working on top of CIoT is, in terms of what we have seen, gives you something like a 30% payload down in terms of consumption. But the importance is not the payload in terms. If your question is the power consumption, if you want to optimize the power consumption, CIoT won't be able to provide you a lot. What will be providing you a lot is diminishing the number of transmission.
Yeah, okay, Olivia, thank you for your answer. We have the upcoming session in a couple of minutes. That is why I try to be faster. Maybe a question to Miguel in the meantime. So Miguel, which technology did you use prior to lightweight M2M by Urban Control?
So prior, I mean, still, we use, I mean, we have a couple of 100,000 devices deployed with Wi-Sun mesh technology. So it's a sub-gigahertz mesh network, which is also very good and very used in dense urban places, right? I mean, if I quickly can compare one to the other, I mean, there's advantages on both sides. Of course, I could highlight, for example, I mean, the requirement of having an infrastructure set up, which with the Cellular NB-IoT and LTE-M we don't. So that's a big plus, I would say. But on the other hand, when we go to large-scale deployments, it may, for example, in terms of cost, it may level one solution or the other. I would say, you know, the coverage it's widespread with cellular. Bandwidth is slightly better. Power consumption is better with cellular. I mean, with a sub-gig, usually you consume more because it's a mesh, and the mesh, all the elements have to participate. So I mean, with the cellular solution, then using lightweight M2M, we have a big plus on let's say on power consumption of the device. And I could compare, for example, latency. We experience lower latency times with the cellular than with the mesh, for example. But still, I mean, they both have their, let's say, positioning in the market, and actually both can coexist and both can complement each other. Because, for example, use a mesh. Sometimes you have shadow places which are on the edge or a bit more further away from, let's say, the center of the mesh. So, I mean, we favor much these two technologies. Of course, we lately are seeing more benefits as we deploy more and more on the cellular side. It's just because, I mean, it's really plug and play, very simple, very powerful in terms of in terms of interoperability, in terms of the freedom that gives to the cities. So anyway, that's my opinion.
Yeah, thank you so much for sharing it, Miguel. And I unfortunately need to end this meeting due to another meeting, but there are a few questions left, and I can contact you and I can follow up with you all via email and reply your questions. And thank you so much, Miguel and Olivier, for this great presentation. I think it was also very interesting for our audience. And we will, as I mentioned earlier, we will also share you the links to get started with lightweight M2M and test it yourself. So you can always test it, and I believe you can always contact us if you have any questions. So thanks everyone for joining today's webinar. And for the questions, they will be sent, the answers will be sent, and also presentation and the recording of this meeting will be sent in a few days. Thank you all.
Thank you, Janset. Thanks so much.